Hey guys, it's Riley. So, for a long time now, I've wanted to do something called Schlieren imaging. Now, Schlieren imaging is basically an imaging technique that allows you to make visible air currents as they move through the air. The way it works is basically that the refractive index of a material is, amongst other things, a function of that material's density. As air currents travel, of course, you can think of it as basically a pressure wave propagating through the material, and that pressure wave corresponds to a change in density. Now, normally these changes in the refractive index of a material is too small for the human eye to see, but using a special technique, which is Schlieren imaging, you can make these changes in the refractive index of the materials visible. Now, the thing that stopped me from actually doing this is that it requires a relatively large parabolic mirror, like what you would use for the primary of a reflective telescope. And these mirrors can be pretty expensive. But I'm actually the current vice president of the Astronomical Society here at Cornell, which means that I have quite a few old telescopes available to me. And so I thought today that I would use one of those old primaries to build a small rudimentary Schlieren imaging setup. So let's get to it. So this is the path to the basement at Fuertes Observatory. It's pretty creepy down here. There we go. But down here in this room, it's basically a graveyard of old abandoned astronomical equipment. And amongst other things, you can see there are quite a few of these old paper tube telescopes. Now, the largest one down here, and thankfully one that was relatively accessible, is this one here. And you can see where I unbolted the mount of the primary mirror, which was sitting in here. It's right there. And I've taken it out of the telescope. It was mounted on this thing, which I've removed. Now, Schlieren photography sounds like something that could have been named after a person, but Schlieren actually does not refer to a person at all. Rather, Schlieren is the plural of the German word Schliere, meaning streak. And these Schlieren refer to these optical inhomogeneities in some transparent medium, in this case air. And these Schlieren were discovered by Robert Hooke in 1665. The imaging technique was further improved in 1859 by Foucault, the same Foucault responsible for the well-known Foucault's pendulum. And then a few years later, improved upon yet again by another German physicist. So here's a rudimentary diagram I've drawn to try and explain exactly how Schlieren imaging works. It starts off with some sort of source of light, which you bring to a collimated pinpoint beam using, for example, some sort of slit or like a pinhole. And now to imagine how this works, let's trace a single ray. So you can take this line of light from the source, and it travels along, and as it gets to some area where there's a density gradient in the air, for example, caused by a hot plume of air rising up over a poorly drawn candle, the light refracts, which is demonstrated here. And then it continues along, reflects off the parabolic mirror, and then comes back towards the camera, or the recording device, whatever you're using. And this represents what is preferably a very sharp blade, like a razor blade, or in my very sketchy setup, I'm actually using a very old pair of scissors. And basically, depending on how the light gets refracted over here, it changes whether or not this beam of light will get bent downward and therefore be blocked by the razor, or bent upward and pass through the camera. And so basically, what this technique allows you to do is visualize these inhomogeneities in the air by either blocking or passing light selectively from those regions, which allows you to visualize denser areas as darker patches and less dense areas as brighter ones. So I'm bringing you over to my setup now. And so you can see what I've got going on here. So I have my DSLR camera, which I'm using to videotape. That torch I was using for some of the experiments with this. And you can see
on the side of my camera, I have very sketchily taped this really old flashlight. So this flashlight's actually kind of interesting. I found it here, and it uses what looks like an LED, but when I took it apart and took it out, it's actually a very small incandescent bulb, which I thought was sort of interesting. But anyway, this is so small, it effectively acts as a point source of light, and so I don't need to bother with making some sort of pinhole system. Now, I actually was thinking that maybe if I built some sort of pinhole type device, it might make the output of this a little nicer, but it seems pretty nice to me so far anyway, so I thought, why bother? So, coming over here, you can see that this is actually the parabolic primary mirror that I took out of that telescope downstairs. And you can see it's a little, you know, worse for wear. It's pretty old. I did my best to clean it up as best as I could without scratching it. And as you can see, I was saying it is pretty thick, which is interesting too. It's pretty heavy. But anyway, this looks flat to us, but it's because it's actually a section of a very large curve. And the focal point of that curve is over here next to my camera. And so now back over here, you can see when I turn on this flashlight, the light comes down this way, spreading as it moves along, contacts the parabolic mirror, reflects off of it, and then the parabolic mirror starts to make it converge again, and it comes down here and comes to a focus. Let's see if I can do this without hitting anything. And comes to a focus right on the edge of this scissor blade. And it's hard to tell because it's so small, but it's very approximately cut in half. And so this is what I was talking about, how some of the light will get refracted identity gradients over there by the mirror, and the refraction causes their path to either be bent into the blade of the scissor, blocking it, or bent away from it, allowing it to pass through. So here you can see what the initial setup of the imaging system looks like. This is just a cup of warm water. And here I put my hand in, and you can actually see the hot air rising up off of my hand, which I think is pretty interesting. And of course, right now it's the middle of winter here, and so I went outside and grabbed a piece of snow, which is what I'm holding here. I was curious to see what this would look like. It seems that the hot air coming off of my hand is overpowering anything given off by the snow. Okay guys, so I've made a few improvements on my super sketchy setup here. For one, I took the flashlight off of the camera, which means that now I can actually spin the focusing wheel and bring the footage into focus, because I think before, it's a little hard to tell, but I think it was actually slightly out of focus. So that should be fixed now. And the way I have it set up now, it's actually a lot easier to position the camera and the flashlight separately, which makes it a lot easier to bring the entire thing into a nice setup. And so you can see on my little display here that the entire thing is actually working pretty well, where before it was oftentimes only a small section of the circle. So I will try and get some more videos from this, and I think they should look a whole lot nicer. So let's see. So here's the new improved setup, and you can see that it looks quite a bit better actually. You could see it even worked there when I had the lights on, which is pretty interesting actually. I didn't really expect it to work with the lights on, or at the very least not to work as well, but it seemed to work just fine actually. Here I am taking out the cup of water again, and then I put my hand in again so you can compare to the previous video. Here I think it was actually like knocking the table a little bit, which was causing the mirror to vibrate slightly, and that's causing those like bright flares on the side. So here I go and grab a disposable butane lighter, and I'm just letting out the butane without lighting it. Now I light it, and when I light it, you can see that it makes a huge difference. There's all of the turbulent plumes coming off from the flame. You can see my breath in the top right occasionally. And here I can blow it out, and you can see what that looks like, which is pretty interesting. So I think this part is the favorite that I did today. It's just a propane torch. You can see the butane coming out of it. Right there I light it with the lighter. And it's really crazy to see how turbulent all the flow is coming off of the very hot propane flame. And this is me blowing into it, and it's just crazy how chaotic it makes the airflow around it. and there I blow it out just like I did with the lighter.
So here at Fuertes Observatory, where I have this apparatus set up, we do a lot of public outreach. Every Friday night from 8 p.m. to midnight, we open up the building to the public. That includes giving tours of the building as well as letting them do observations through our historical telescope upstairs in the dome room. But here in Ithaca, New York, in the great north, it's often very cloudy and overcast and just in general not very good conditions for observing. So I was thinking that it could be interesting to, on occasion, set up the Schlieren imaging apparatus and let members of the public put their hands into it and see the recordings of the videos and give them a little explanation about what it is that they're seeing. I think that could be pretty cool. So that's it for this video. If you guys have anything you'd like to see me put into the apparatus, let me know down below, and if I can do it, then I will. Until next time, have a great day.